Good afternoon and welcome to Geometry. Well, this should be a fairly easy lesson for you, as in, I'll talk for a few minutes and explain this to you, and then you only have 4 problems to do for your homework today, and then, of course, test tomorrow. So, this is a little bit interesting. Rotations and reflections in the coordinate plane, lesson 105. But we need to start out, before we get into rotations and reflections, understanding multiplication of matrices. And I don't consider this the easiest thing I've ever learned or taught. In some ways, it's maybe, I don't know, it's a little bit odd, I think. But it is powerful, and we use it a lot in finite math. They use a lot of matrices. I took linear algebra, which was all matrices. And we actually do use something along these lines in some of the physics classes that I've taken. But anyway, we're going to use it in a different context here. So we're going to multiply two matrices. Now, there is an important rule. The number of columns in the first factor must always equal the number of rows in the second factor. And that's because of the way we multiply. And let me show you how to multiply matrices. I numbered the squares 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are actually numbers in the matrix, but I'm going to use them kind of to identify where I am also. So they're doing double duty. They're a value, but they're also a location, if that makes sense to you. Because the way we multiply these, we have matrix on the left there, 1, 2, 3, 4, and matrix on the left, on the right, 5, 6, 7, 8, 9, 10. How do we multiply that? Well, the first step is to do this. I'm sorry, it looks really complicated because I didn't go take the time to make it animate and each cell come in separately. First cell, that's the top left corner. And you're going to take the first row and you're going to multiply it by the first column. Okay? So 1 times 5, that's the first square in the row and the top square in the column, 1 times 5. And then we're going to add to that the second square, which is 2, and the second square, which is 8. So 1 times 5 plus 2 times 8. So we're multiplying the first row by the first column, and that goes in the first row, first column, in the new matrix. And you multiply the first 2 squares and the second 2 squares and add them together. If you go to the right, first row, second column. So you take the first row, 1 and 2, second column, 6 and 9, 1 times 6, 2 times 9. Okay, so we're multiplying. It's like we're taking the row and we're swinging it 90 degrees and dropping it on top of the column and multiplying. So 1 times 6 and 2 times 9. Then we take, for the next box, first row, third column. I hope you guys can keep track of rows and columns, because if you can't, you're going to be in trouble on this thing. First row, third column. So we take the first row of the first matrix and the third column of the second matrix. 1 times 7, 2 times 10, and we add those together. Okay? First row, third column, first square is 1 times 7, second square is 2 times 10. Now we go to the bottom row of the product, and we are going to do second row, first column. So we take the second row of the square, multiplied by the first column of the rectangle. So 3 times 5 and 4 times 8. Once again, we're taking that second row, kind of spinning it 90 degrees and dropping it on top of that first column. 3 times 5 and 4 times 8. Now, the middle bottom, that's the second row, second column. So we take the second row of the square, put it on the second column of the rectangle, 3 times 6 and 4 times 9. Okay, first square, second square. 3 times 6 plus 4 times 9. For the last square, which is the second row, third column, 3 times 7 and 4 times 10. Again, we take that second row, put it on the third column, 3 times 7 and 4 times 10. Then we do the multiplication, and I went through 1 times 5, 2 times 8, 1 times 6, 2 times 9, 1 times 7, 2 times 10, 3 times 5, 4 times 8, etc. And then we add them together, and you get 21, 24, 27, 47, 54, and 61. That's how you multiply matrices. Okay? Now, we're going to use this in a particular context. They're not just teaching you matrices, they're teaching you geometry. So, if you're doing reflection, this is in your textbook. You're simply going to have to memorize these. You're not going to you're not going to get these unless you just memorize them, all right? So, when you're reflecting around the x-axis, your matrix that you're going to multiply by looks like this, 1, 0, 0, negative 1. If you're reflecting around the y-axis, negative 1, 0, 0, 1. Okay, so these are fairly simple. I'll show you an example of how to use these, but this is fairly simple. What about rotation? Now, these are ones that I find, we've done rotation around the origin of them and a little bit challenging. Well, this matrices, it actually kind of is easier, or at least it's one way to do it that isn't any worse than the others. For 90 degrees, 0, negative 1, 1, 0. 180, negative 1, 0, 0, negative 1. 270, 0, 1, negative 1, 0. And 360, 1, 0, 0, 1. I'm not sure why you'd want to rotate 360 and go through any math, because if you rotate 360, you end up where you started. But this is a matrix for how you would do that. Okay, so x-axis reflection. Okay, so we've taken this triangle and turned it into a matrix. First point 1, 5. I chose that to be the second point 3, 5. And then the last point, of course, is 1, 2. First row is the x's, second row is the y's. We've done that earlier. You remember from the earlier slide, before you go back to the earlier slide to find it, the reflection matrix for the x-axis is 1, 0, 0, negative 1. Okay? So then we multiply these two together. And what does that equal? Well, that would equal, well, let's see, we have 1 times 1 plus 0 times 5, right? So follow with me. First row, first column. So 1 times 1 and 0 times 5, that's 1. First row, second column, 1 times 3, 0 times 5, that's 3. 1 times 1, 0 times 2, that's 1. That's the first row, third column. And you see what it did? By multiplying that matrix, we simply copied the first row. Second row is 0, negative 1. So 0 times 1. Okay, first square, 0 times 1. Negative 1 times 5 gives us negative 5. 0 times 3 is 0, plus negative 5 is negative 5. 0 times 1 is 1, negative 2 is negative 2. And you see what it actually did. It went through and flipped all of the y's to negatives. And I didn't redraw the triangle, but you can kind of, if you graph that, you can see how that is a reflection across the x-axis. It just flipped all the y's. Okay. Rotation, 90-degree rotation. Once again, turn this into a matrix. Same triangle, same matrix. But for 90-degree rotation, we use this one, 0, negative 1, 1, 0. Okay? What does that equal? Well, let's do 0 times 1 is 0. Negative 1 times 5 is negative 5. 0 times 3 is 0. Negative 1 times 5 is negative 5. First row, third column, 0 times 1 is 0, negative 1 times 2 is negative 2. And you see what that's done? It's effectively taken the y values, made them negative, and dropped them into the x spot. 1, 0, 1 times 1 is 1, 0 times 5 is 0, so that's 1. 1 times 3 is 3, 0 times 5 is 0, so that's a 3. 1 times 1 is 1, 0 times 2 is 0. And so you get, effectively, it's taken the x values and dropped them into the y row. Okay? So that's what you're doing. You're just taking a matrix, multiplying matrices, and these are very simple matrices. The one I did at the very beginning was more complicated, and they do that kind of thing in some contexts. But for this context, that's all we're doing. It's just multiplying by ones and zeros. And all of these matrices had a lot of zeros, which means you're not really getting a lot of adding involved. You're getting just multiplying by ones and negative ones and moving stuff around. But it works. Okay, and again, I didn't graph this one, but if you were to graph it, you would see that I rotated that was rotated 90 degrees. Okay, so you have 4 problems to finish, numbers 1, 11, 18, and 24 on lesson 105. And just comment on the text. Somehow this felt like turning all about, spinning around on these things. Anyway, so do those last 4 questions on lesson 105, and then you can turn that in. All right. Thank you very much. Have a good day.